So hello, this is lesson 7 with trigonometry, functions, and graphs. And we're finally back to looking at SRT. SRT, stretches, rotations, and translations, focusing on letters that are pretty similar to what we saw before, at least their locations are the same. Take a look at the general statement for sine and cosine graphs, and then there could be a similar statement for tan graphs as well. Our focus is primarily on sine and cos, but we do need to be able to deal with tan as well. You can throw these graphs in your calculator, but you can perhaps anticipate what happens when we manipulate the coefficient of A. The coefficient of A is going to take my sine statements and multiply them by 2 or 3 respectively. That's going to result in those vertical shifts, those vertical stretches. So I have a vertical stretch that is going to be 2 times. 2 times. So I'm going to be 2 times larger. With the -3, I have a vertical stretch, plus I have a reflection. I have a reflection with my y's changing to -y's, which means I'm reflecting in the x-axis. And I have a vertical stretch by 3 times larger. So the verticals always were a direct reading, but my x manipulations, remember they're opposites. So here I have a horizontal stretch that is going to be a half time smaller. Here I have a horizontal stretch that's going to be a 3rd time smaller. Plus, it's changing my sign. It's changing my sign from x to -x, which is a reflection in the y-axis. How do these numbers affect amplitude and period? Well, period, you might get a sense as to what it's connected to. Amplitude is connected to my y's. Amplitude is connected to the numbers that are in front. So when those numbers in front are 1s, my amplitude is 1. So going down, I have an amplitude of 1. Going down, I have an amplitude of 1. Here I have an amplitude of 8. That's the general drift of what we're trying to come to terms with. As soon as my number is no longer 1, it actually is my amplitude. So 2, 3, 5, a third. Amplitude is generally referenced as an absolute value because it's the distance up to the trough, or up to the crest, down to the trough or up to the crest. Period is controlled by the value in front of the x term. So period is controlled by the number in front of the x term. So we've got a variety of numbers to look at. In general, the period is 2 pi for sine and cosine graphs, or 360 degrees. And I'm going to get period by taking 360 and dividing by the b value, or 2 pi and dividing by the b value. So where my b values are 1, my period is the same as what we saw in graphs yesterday. 360 degrees, 360 degrees, 360 degrees, remember, or 2 pi. And then the rest of them have to do I have to do a little bit of work. I have to take 360 and divide by 2. Here I'm going to have a period that is shorter, 180 degrees. Here I'm going to have a period that's also shorter, 360 divided by 3, or 360 divided by 4. 360 divided by 3 is 120. 360 divided by 4 is 90. And then with the half, what does that do? 360 divided by a half actually takes me up to a period of 720 degrees. So here's my policeman reporting on how to find all the things we've been talking about: amplitude, period, and period for a sine and cosine graph. And it brought in the tan graph. The tan graph is not quite as dramatic or as common, especially for regular behavior of regular phenomena. But it has a period that's smaller. It has a period that's 180 degrees. Or pi. So add these formulas to your study sheet. They will be critical for the work that we are doing. Hints for graphing them manually. Sometimes you're going to have to graph manually or model it. You can always use your calculator, but sketch the primary trig ratio based on what you know from our work with lesson 6. Adjust the basic graph for changes in amplitude. And then adjust the new graph for any changes in period by dividing the period into 4 parts using the maximum and minimum points and the points where the graph intersects that in midline, the horizontal line running through the center of the graph to help you figure out amplitude and period. Got a few nice examples to look at. State the amplitude and period and then try to sketch the graph. Remember, amplitude comes from that first leading number, so my amplitude is going to be 4, and my period is controlled by, I'm working in radians for this graph, so I have to take 2 pi and divide by 2. So my period is going to be pi. That means that by the time I get to pi, I will have completed a complete cycle, a crest and a trough. And this is a cosine graph. Remember, a cosine graph starts a little bit differently, so we need to think about how we're going to adjust for that as well. So the scale of this graph was a little weird for me. I need to understand dividing the graph up into 4 parts horizontally. So I took my pi, and I actually first found pi over 2, which is in the midpoint of my lines. And then I split that into a half again, but it was over 3 lines. So I've got my region of pi divided up into 4 segments, 4 equal segments. And I've got the starting of a cosine graph up at the y-intercept, which is up at max amplitude. Then it dips down and comes back up. And I can keep drawing those segments. I'll add to my scale. So in a region of 2 pi, I'm going to get 2 complete periods. Talking about period on a cosine graph is a little bit interesting, especially if you start at the y-intercept. So you can start at the y-intercept, count half a crest. So then half a crest, a full trough, and then the other half of the crest on the other side. And you can graph that on your calculator. So now we have to do some writing, sliding down. So if I know I have an amplitude of 2/3, I know what my A value is. My A is 2/3. And my B value is controlled by my period. Period is 2 pi. 2 pi divided by B is supposed to be pi over 6. A little bit of algebra to solve for my B. Excuse my B's and 6's looking the same. This is my B, I'll circle that. So B will be 2 pi divided by pi over 6. The pi's actually cancel and give me a B value of 12. So that if I want to have a sine function, it will be y equals 2/3 sine of 12x. Put brackets around that. A cosine function having an amplitude of 3 and a period of 720. Again, amplitude is my A value, and that's 3. We're talking about a cosine function with degrees, so that's nice. So 360 divided by B is supposed to be 720. We've seen this already, actually, and you can solve for B. So I did a little bit of studying of these graphs. The amplitude of class example 4 is 3. The period is pi. I have a crest and a trough that takes place in a horizontal length of pi. Amplitude is my A value. Period contributes to my B value through the formula we've been talking about. Period equals 2 pi over B. And that period is a known value. So I get B equals to 2. So that final statement ends up being 3 sine 2x. And then we've got a modeling of trigonometric equations for the next one. I've got a graph to study. I highlighted the graph to get an identification of the period. So half a crest plus a full trough and half a crest is a length of 12 on the horizontal axis. So 12 is right there. That's going to help me with my period calculation. Period is 12, controlled by the formula 2 pi over b. Manipulate that for b. And my amplitude is 4. I can read that straight off the graph and report my equation as h at t equals 4 cosine pi over 6. But I should use a t, not an x, because I'm tracking time. That's it for this lesson. You can imagine what the next one is.